Hi, welcome to All About Mechanical Engineering. Today we will study the Carter carburetor. This is the schematic diagram. Carter carburetor is an open choke type of carburetor. It is an American made carburetor manufactured by Carter Company founded by William Carter in 1909. It was basically designed to be used in Jeep. Let us understand the Carter carburetor and the various parts. Starting with the first component here, this is the float chamber. Second component, this is the float. The third one here is the metering rod. The fourth one is the metering rod jet here. The fifth component here is the idle jet screw. The sixth component here is the idle port. The seventh one here is the low speed port. Eighth component, this one is the throttle valve. Ninth one, this small compartment is primary venturi, whereas this small opening is the jet. This larger component is secondary venturi, and this broader area is the tertiary venturi, or also called as main tube. This component is the choke, that is number 13. Then this portion, this small port is low speed jet. Then this passage from here is number 15, air bypass passage. Then 16th number here is fuel from float chamber to the accelerator pump. And 17th one is the outlet from acceleration pump. So these are the various components of Carter carburetor. Now let us try to understand various circuits under various conditions. So cold starting and warming. Here color lines are indicated for various supplies. Blue will indicate fuel supply, air supply will be indicated by brown, and this bright brown will be used for air fuel mixture. So during cold start, using choke, the air supply is being blocked. So minimum amount of air enters the carburetor, because of which 5 to 10 times richer mixture will be created, which is necessary for the cold start. So this air is given to the primary venturi here up to this component. From the float chamber here, the fuel is supplied to the primary venturi using this jet. Here in this primary venturi, air fuel mixture is formed, which is a very rich mixture, which then travels to the secondary venturi. From there on, traveling to the main tube and traveling across the throttle, carried forward to the engine. Now, once the engine gets started, during the warm up, this semi automatic choke here is going to automatically open up to 50% of its capacity, thus increasing the amount of air supply, and the richer mixture is now converted to a lean mixture. So now the rich mixture is not there, it is going to be having a leaner mixture which is being provided to the engine during warming. Now during idle and slow running. So here the circuit for idling is this incoming air is going to take this passage here and enters this low speed jet. From the float chamber, the fuel takes the low speed passage here and reaches up to this port here. So this is a jet which is low speed jet. There the air and fuel mixture gets mixed, forming a mixture, and from there traveling down to the idle port here, which is below the throttle valve. So obviously, even when you are not operating the throttle and your vehicle and your carburetor is in idle condition, the air fuel mixture will be delivered to the engine, which keeps the engine running without operating the throttle. Once you are having a slow running condition, which means 20% of the total load capacity, then this throttle will be opened here, and hence this port, that is low speed port, will come into picture, and instead of traveling to this port, the air fuel mixture starts to come out from this low speed port and then given to the engine. During normal running, you have the capacity more than 20% of the load. You have this float chamber with the fuel supply. As you accelerate, this metering rod will be pulled up, because of which this throttle being operated, and it creates a suction on this air supply here, traveling all the way down to the primary venturi here, and creating a suction from this float chamber, taking the fuel from this jet into the primary venturi. They are forming an air fuel mixture transferred to the secondary venturi, and there is excess amount of air which is again mixed in the main tube, forming a leaner mixture required for normal running. Then this mixture is being passed on to the engine. What happens during the sudden acceleration? So we have this normal working going on, and you suddenly accelerate. So what happens to working of this carburetor? So this is the throttle right now during the normal running, and if we suddenly accelerate, this throttle is going to be more open, creating a more suction. Then this circuit for the acceleration pump comes into picture. So we have this inlet for the this pump from the float chamber, from where the fuel is supplied to this pump, and when you suddenly accelerate, this piston is being forced down because this arrangement is connected to your accelerator pedal, thus forcing some amount of extra fuel into the main tube and mixing it with the air fuel mixture which is already being prepared during normal working, and an additional amount of air fuel mixture or more amount of fuel is being added in order to cope up for the sudden need of acceleration, and which is given to the engine. Hope you have enjoyed the video. See you again with another video.